After a group meeting, we decided upon using Concept B as our base design. We set about improving upon the design. We discussed how the design as it stood would not work due to the driven wheels on either side causing the whole device to rotate and thus fall out of the pipe. After realizing this, we set about improving upon our design. And we did this by putting both sets of driven wheels on one side of the device and the opposite having a spring-mounted caster to help provide the required traction. This would aid the machine climbing the pipe, and the spring-mounted wheel will also enable our device to be adjustable to fit various sizes of pipe. The device would be easily adjustable to fit a varying range of pipes with only a simple modification of changing the spring and its mountings for bigger diameter pipes or smaller springs for smaller diameter pipes. We decided on using small motors with worm drives, but these are easily changeable for larger motors if they do not provide the required power. The device as it is oversized for the particular pipe we have to use. This gives us a variety of options to use different sized drive wheels when we find the ones we need to use.
Once we had finally chosen our design concept, we identified a few problems and came up with solutions to them. This includes mounting all of the driven wheels on one side to keep the drive simplistic, and now using a spring-loaded caster wheel on the other side to keep the drive and traction. We also identified the type of power outlet we would need, as well as the motor needed and the mechanics and circuitry needed to get the device up and down the pipe in a decent competitive time. As a material to use as a base, we thought we would use aluminium as it is light and quite strong. We also thought we would use a sheet 1.5mm thick and possibly 200 by 500mm in height and length. This would give us ample material to cut and bend into shape and mount all of our components to. Another component we needed identifying is the wheels. We needed wheels which would be small enough to fit in the tube but big enough to create traction and get the device quickly through the pipe. Our current idea is to use a set of rubber RC car wheels, roughly around 30mm, as the rubber would create traction.
After doing some research about the project specification rules set out by the Institution of Mechanical Engineers, I realized that our initial idea about using a pressure switch to turn the device off once it hits the top of the pipe and allow the crawler to slowly return to the bottom by gravity would not work, because the device must reach the starting point before the timed run will stop. My solution to this will be to use a DP-DT switch, which is basically an on-off-on switch. This will be used to reverse the polarity of the motor so that the device can power itself back down to the starting point. Our trigger mechanisms that we will use to send a signal back to the DP-DT switch will be snap action switches. I chose these because they are very sturdy and will be able to withstand hitting the top of the pipe repeatedly. Another reason why they were chosen is because the snap action switches do not need a lot of movement to trigger them, and this will be ideal if the device behaves differently and does not reach top of the pipe as fast as we anticipate. We have chosen to use the MM28 electric motor and worm gear setup because based on a final device weight of 1.25 kilograms, which includes the added chain weight at a height of 2.3 meters, we would need 7.7 watts of power to climb the pipe in 3.5 seconds. And since each MM28 motor is capable of producing 5.8 watts of power at 9 volts, we chose to use two MM28 motors. Because the motors are producing more power than needed, this will hopefully allow the device to climb the pipe in a range of 2.5 to 4.5 seconds, depending on the traction that is obtained. And from research, we know that if the device can climb the pipe in that time, we should be very competitive. Secondly, using a worm gear setup allows for higher torque values to be transferred from the electric motors to the axles. This also allows us to mount the motor vertically while having the axles 90 degrees to the motor, which will be perfect for achieving traction along the pipe walls. And lastly, the motor and gear combo is easily interchangeable with other electric motors, which will be handy if we find that we need more or less power based on the final weight of the device. Another key decision that was made is to use two single 9-volt batteries to power the motors instead of creating two battery packs out of 12 AA batteries. And although the AA battery packs will last much longer and produce a higher voltage for a longer amount of time, we decided that the weight savings from using just two single 9-volt batteries instead was a greater advantage, especially since the rules state that batteries can be interchanged in between runs and the team will not be penalized. This means that we can allow the 9-volt batteries to fully discharge during a run and not be worried about how much energy the battery still has.